Today I'll be making copper 2 acetylsalicylate, also known as copper aspirinate. Copper aspirinate is formed by chelating copper ions with acetylsalicylic acid, and according to Wikipedia is considered to be an effective treatment for rheumatoid arthritis, and is being explored as a potential treatment for thrombosis. It also has use as a pigment for different polymers. In order to synthesize this compound, I only need a few materials that can be readily found at local retail stores. Sodium carbonate, also known as washing soda, and is used as a laundry additive. Copper sulfate pentahydrate, which is sold as a root killer. Acetylsalicylic acid, also known as ASA. This is sold as an anti-inflammatory drug most commonly known by the brand name aspirin. And then distilled water and acetone, which I didn't show here. While I didn't record it, I started by extracting the acetylsalicylic acid from the aspirin tablets. I essentially crushed them up and dissolved them in a copious amount of acetone, and then filtered off the solid filler material and left the acetone to evaporate, which resulted in these fluffy white crystals. Next, I will make a small batch of basic copper carbonate. I start by measuring out 64 grams of the copper sulfate pentahydrate and 24 grams of the sodium carbonate. I then add 175 milliliters of distilled water to the copper sulfate and turn on the heat and stirring and wait for all the crystals to dissolve. Since I'll be collecting the resulting precipitate of the reaction, it's important to run the solution through a coffee filter to remove any undissolved solid impurities. Next, I add 50 milliliters of water to the sodium carbonate and repeat the same process of heating and filtering off the solution. Next, I pour the sodium carbonate solution into the copper sulfate solution. This begins a double displacement reaction that produces the highly water-soluble sodium sulfate and an insoluble basic copper carbonate, as well as a significant amount of CO2 gas. As the mixture reacts, I quickly stir the foam that's forming on top to liberate the gas and prevent the foam from climbing too high. However, as I was mixing the reaction, I got a little distracted while filming, and the foam did nearly climb its way out of the beaker, but thankfully my frantic stirring was able to keep it in check. I throw the beaker back on the stir plate and let it stir for several minutes until I feel that there is no more CO2 gas being let off, indicating that the reaction has run to completion. I then pour the solution over a coffee filter, and after letting it drain for several minutes, I add another swig of hot water to dissolve as much of the remaining water-soluble impurities as possible. I initially placed the resulting robin's egg blue paste into my desiccator, but decided it made more sense to just throw it in the oven for a couple hours to evaporate the water. After a couple hours at 250 Fahrenheit, I pulled it out of the oven and ground it up into a fine powder using a pestle and mortar. I ended up getting exactly a 100% yield, which indicates that there was likely some humidity in the powder still. I weighed out what I needed for the next reaction and stored the rest into some glass bottles. Now it's time to make the copper aspirinate. I started by measuring out 18 grams of the ASA and 6 grams of the copper carbonate. I then added 75 milliliters of water to the ASA and cranked up the heat and turned on the stirring. For this reaction, I'm using an excess of ASA to ensure that all of the copper carbonate reacts. This way I can simply wash the final product with some acetone to dissolve out any extra ASA or any salicylic acid that inevitably forms during the heating, since copper aspirinate is insoluble in acetone. Once sufficiently heated, I began slowly adding the copper carbonate. The copper carbonate will react with the ASA and water to form CO2 gas and a dark blue precipitate, which will be our copper aspirinate. I incrementally add all the copper carbonate to control the CO2, then once it's all added, I let the mixture continue to stir on low heat for about another 10 minutes. Upon removing the solution from heat and turning off stirring, the copper aspirinate began to quickly separate from the aqueous layer. As the solution cooled, white needle-like crystals of ASA began to crystallize out in the aqueous layer, which created a pretty cool visual. I then filtered the solution, and crystals of excess ASA can be clearly seen mixed with the precipitate. I put the solids back into a beaker and added acetone, spilling some in the process. After getting that cleaned up, I stirred the mixture for a couple minutes to dissolve any of the acetylsalicylic or salicylic acid. It was then filtered, and I was left with a pure copper aspirinate precipitate. I then let this air dry and placed the final product into some glass bottles. The final yield was approximately 75% of theoretical.